We were discussing about in the last part of the lesson that you have a conical flask that is look like this, and here you have a burette. From the burette the acid is coming out, and in the conical flask you have base or alkali, and you add few drops of indicator to change the color of the base. Now what you do, drop wise you pour the acid drop wise and find the end point. How you find the end point? Where this color of the solution is changed. As the color of the solution changed, you mean to say that is the end point. And from here, how much solution, mean to say acid, you used, you can note from here. The experiment is then repeated without using the indicator. First, you need to use, because that time you don't know where the color changed. So once you know the end point, for example, this color change after using of acid, mean to say 10 ml, for example. So next time when you repeat the experiment, that time you no need to use here indicator. You only take the amount of alkali or base and then add 10 ml of acid and you get here a solution. Okay, so then the repeated without the indicator. Alternatively, the
activated.
activated conical, I don't know, China coal. Yeah,
Chain call.
yeah. Chain coal can be added to remove the indicator. So this also a chemical that you need to add in it that will going to uh, remove the indicator from the solution. The charcoal can then be filtered off. Whatever you add in it, it will take all the indicator, and after that you can use like this. You will pour this here and down. You can get your again solution in the beaker after filtrating. Heat the solution till the point of crystallization. Now you take this solution and start to heat it. When you saw there are crystal formation, wash the crystals with distilled water and leave it to dry. So in the second way, the second method to prepare a soluble salt by the help of titration. Both were done very well and easily.
Teacher,
Yeah,
from where the charcoal come?
you buy from the market and you use it.
I
Okay,
meant why?
to change the color or absorb all the indicator from the solution. Okay,
To change the color of the solution.
yeah, take out the indicator because you add the indicator in the solution because you want only the salt, you don't want indicator in it. So how you can get out the indicator from this? So it tells you you need to add charcoal or China activated China coal like this. I think this is also a charcoal, not China any word here. This is activated charcoal only. Okay, now the
Yes,
third
it's
method.
not.
Sorry,
I said this. It's not China call.
yeah, it's charcoal, activated charcoal. Okay, the third method, that is about the precipitation. See, two soluble salts. Yeah, I read well.
Two
This,
soluble salts. Yes.
yeah, okay. If
Wait.
somewhere due to the print color, I pronounce or read wrong, please make me correct. Okay. Now, what you need here, I think that you write here beakers, Beakers. Yeah. Number
Yes,
one,
beaker.
beakers. Yeah.
Yes. Filter
Filter
paper
paper
and filter funnel.
and filter funnel. Same like this. Okay. Precipitation, reaction in which one insoluble salt is prepared from the solution of two soluble salts. How? let's see this method and the procedure here. Number 1, to choose soluble salt or to be gently, what this word?
Teacher, the Mississippi precipitation, this is insoluble salt.
Yeah, insoluble. Okay. Choose a soluble salt to be what this word?
Question, I think.
What?
To choose insoluble salts are to be taken and gently mixed together.
Yeah,
Take
gently mixed together. Okay, taken and tea. It's tea. You can read on this tea. Wallahi, I
taken.
can't. Yeah.
This is not my answer.
Okay, taken and gently mixed together. First to choose 2 salts. Okay, soluble salts. Then number 2, precipitate can be filtered out. When you mix them, you can find there the precipitate. Now what you do, the precipitate you can filter out, wash the precipitate with distilled water and leave it to dry. And in this way, you can get your precipitate, or the method C, the salt from the precipitation. Okay, done.
Yes.
Now examples of precipitation. Which kinds of salts that can give you precipitations, okay? Now let's see this one. Bismillah. Here, what it's going to tell you. An insoluble salt, I think barium sulfate, yeah, Ba. Barium sulfate, because I read from here. Barium sulfate can be made by mixing 2 soluble salt, barium chloride and sodium sulfate. This salt, how you get? He tell you when you mix with salt, that one is barium chloride, yani BaCl2, and second sodium sulfate. You know very well, sodium NaSO4. These two. When these 2 salts combine together, then what you get? You get barium sulfate, BaSO4, and also it gives you 2 sodium, Na. Understand? Easy,
Yes,
my dear? Okay, that's great.
Alhamdulillah.
Very simple. This is a precipitate equation also written here. This one. Okay? Easy?
Yes. Alhamdulillah.
NaCl also come with it. Here also you need to write. I think you remove here the Cl, it will be here, okay? NaCl. Because where the chlorine go, it will be broken down from here and it will be gone there. Okay? So this is incomplete. NaCl. Okay? Check the equation.
Yes, okay.
Please verify, because if you miss some words, then it's only written like as nitrogen. Even you not have nitrogen in the whole reaction. It is sodium actually. Yeah?
In my notebook, it's written BaSO4 plus 2 NaCl.
Yeah, I'm right. Okay. It means it's like this. As I wrote. You can see the screen here, yeah? 2
Yes.
NaCl.
Okay.
Okay, complete this one also. Okay, now let's go down to after understand this.
Yes.
Okay, now feel easy, relax.
Alhamdulillah.
And Mr. Amro, you?
He's not responding, sir.
Oh my God.
And
Wallahi, responding when he was alone. He's sending me the messages. Okay, now define. Yes, look, he sent the message. That's a great. Oh my God. Even he don't reply. Now he reply, Mr. Explain again. Auzubillah. Okay, no problem. Yes, a good message. Wallah, a good message. Look this one. No problem. Look how you can make insoluble, okay, salt. For this, if you want to prepare barium sulfate, you want this, that is your insoluble salt. Mean to say that you get in the form of precipitate or in the form of precipitation. How you get it? You need barium chloride, BaCl2, plus sodium sulfate, Na2SO4. When they both react together, this bond is broken from here and this bond is broken down from here. Okay, so BaSO4 combined together, then what you get? BaSO4 plus this chlorine and sodium combined together, and what you get? NaCl, sodium chloride. Now, Mr. Amro, easy?
I ask a stupid question, but
No, don't think like that. Ask.
why you put the Na first, not sir?
Yeah, okay, no problem. Look, my dear, every time when you're going to write any molecule, you first write the positive element, okay, or a species that have positive charge. Here sodium has positive and chlorine has negative. Okay, every time when you're going to write any, can ask anything, even if it's the question of what the teacher for dinner, what the teacher ate for dinner, anything, even if it's a question of what the teacher ate. Amro, can you ask me what you want to ask? Clear this one. Okay, and also here, what your name? Ahmad, look, HCl. Okay, H positive, chlorine negative. Okay, NaOH.
Yes.
This OH is negative, this is positive. Even H individual is positive, but here H combined with O. Okay, that's the reason. So in this way you can get.
So Na is a positive charge and Cl is the negative charge.
Yeah, first positive charge element or the species or the molecule will come, then the negative charge. Okay.
How did I know that Cl is negative?
Yes, that's a good question. For this, you need to know the periodic table. You need to learn about the elements they gain electrons and which elements they lose electrons and how they become a positive or negative ions. Okay. For this, you need to understand the periodic table in detail. Like metals, how? It's not a difficult task. All metals like sodium, potassium, calcium, they all lose electron and they get positive charge on them. Understand? That's the reason they are
Yes.
written first. Or all the non-metals like chlorine, bromine, iodine, they all gain electron. -1, -1. Oxygen gain 2 electron. So that's the reason they came last. Understand? Or explain more? Yes, Mr.
Yes.
Ahmed.
Yes, I understand.
Okay, inshallah. As we going on, the things will come. I will explain you all one by one. Okay, so here define titration, a method of quantitative analysis using solution. I don't know. One sodium is slowly added to a known volume of another solution using in burette until one endpoint is reached. During titration, when all the acid has just been neutralized, is as endpoint. Okay, I will tell you. I don't know what's written here, but I'm going to explain you about it. What happened during a titration? It is a method that is a quantitative. there are two types of reactions, or you can say that techniques. One is qualitative, second is quantitative. Do you have any idea or any difference between them?
No.
As the names of the techniques going to tell you. The first, as mentioned here, quantitative. Quanti mean quantity. Yani miqdar, you can say that. Quantity. How much? Okay? If
Yes, sir.
during an experiment, you going to find out quantity of something, this type of technique or analysis is named as quantitative analysis. Understand?
Yes.
Second type of technique is qualitative. Qualitative. Quality mean to say quality.
Good.
Yani how the thing, it is good,
How is the good?
yeah, it is good,
No.
very good, or very bad. But here it's not mean that. Here we're going to check the amount in it. Okay, which kind of things are there? So what the quality of that thing? Understand? For example,
Yes.
you're going to analyze a milk. How much water is present in the milk? That is the amount of also a quantitative as well as a qualitative. When you know that in 1 glass of milk, somebody add 500 ml of water, so it's meat, its quality is also not good, as well as quantity. Understand? Yes, Mr. Ahmed. Easy?
Yes, sir.
Okay. Now let's go down to see the remaining part. And almost we have lost 10 to 15 minutes. Okay. I inform you before. Okay, so here during titration, when all the acids has just been neutralized, it has an endpoint. Why? Because we can find the endpoint with the help of the indicator. So universal indicator, a mixture of indicator that has color in different solutions. Role of solubility, all salt of sodium, potassium, and ammonia are soluble. This is solubility. You know very well. For example, you take a pinch of salt and try to dissolve in water. If it is, you can't find anything in the water, it means it is soluble. For example, sodium chloride, you know very well, this NaCl, when you dissolve in water, you didn't find NaCl, where it go? Because it's just dispersed in the solution. Same like potassium, I don't know what you write here. Promit and ammonium chloride, and in the same way, soluble in water. They all. It's just going to tell you about this. Okay. Next, what is written here? All nitrates are soluble. Sodium nitrate, potassium nitrate, and calcium. Here, C will be smaller, not capital. Please don't write like this. There is no Ca element in the word. This Ca like this. Okay, that is a way rule to write, how to write the symbols. Understand? Like here you
Okay.
wrote it. Don't done these kinds of mistakes. Okay.
Not
Next.
me, sir.
Sorry,
It's not me.
it's better whatever you wrote well, send me that. If first, it's also to make you to understand the writing, and if there is also mistakes there, it's making me more crazy. Understand? So please. Okay, so all chlorides are soluble except silver. EDTA, I think. Silver chloride.
Lead.
Huh?
Lead.
LEAD. Yes, PB mean to say.
Yes.
Yeah, okay. This lead chloride, PB, its formula is PB, okay? Calcium chloride, CaCO, CaCl2. Potassium chloride, KaCl2. Magnesium, MgCl2. This C should be capital, okay? You know very well, okay? The first letter of the symbol will be capital and second will be smaller if there are two. The first one will be the uppercase and second will be the lowercase. But in case of here, if you have only one letter, the first will be in uppercase, like nitrogen. But if in the case of sodium, you need to write like this, okay? So soluble in water, okay. Now let's go to the, I think this will be the final part. Yeah, all sulfates are soluble except barium sulfate, that we already done in detail. Okay, calcium sulfate, lead sulfate, or are insoluble in water. All carbonates of sodium, potassium, and ammonium are soluble in water. Sodium carbonate, NaCO3. Here O will be capital. My dear, please, this carbonate, okay? This symbol is for cobalt. But if you write like this CO3, then it's carbonate. Don't forget and don't miss this.
Sir, what is the with the small O? What is it?
Small o mean nothing. If this small o comes with CO, it means that is cobalt. If
Copper.
Cu, that mean copper. If only C, that mean carbon. If C and O will come, that mean carbonate.
Okay.
Teacher, explain the important thing again. Can you tell me what are the important things? I explain you all important things, my dear. I didn't like anything, even something you mention here wrong and any spelling mistake. I even going to remove this one also and make it clear. No problem. You can see my video. I mention everything is there. Don't worry. Okay. So now done this. No problem. A quick review. Let's start to see. No problem. I'm going to give you a quick review of this lesson.
Send you the pictures, the continuation.
Sorry?
Because there is an ionic equation. I send you the picture. WhatsApp.
No problem. I will see again. Ionic picture. Oh, ionic equations. Okay. I
Yes.
understand what you mean. Now I understand. Don't worry. I will see here. Where is your this you here? Give me only 1 minute. Yes. Okay. Equations. You want to know the equations, yeah? MashaAllah. Kathir and Kathir. Yes, Ahmad, you can see the screen
No, I
of
cannot.
now.
Now I see it.
Yeah, you want to see these things, yeah?
Yes, of course.
Okay, no problem. Now let's see. And maybe that will be the last of the lesson,
Wait,
okay?
not this. Not
But,
example. Ionic equation.
okay, look this one.
Before this.
Sodium hydroxide, NaOH. You're going to react with copper sulfate, CuSO4. This molecule broken from here and this one is here. Understand? Now this sodium and sulfate combined together, what it's make? Sodium sulfate. This point is okay. And this copper and OH combined together and that make here copper hydroxide. Understand? Yes, my dear.
Yes.
Now the
Of
same
course.
thing, it's going to telling you here down by splitting them into positive and negative charges. Okay?
Yes.
There is no change. Only it's make the charges and just telling you this will go there and this will go there. Okay.
Yes.
Now, see, this is the second part. OH negative go towards copper positive, and then they make copper oxide, just same like here. And these two, sodium and sulfate, they combine together, and you can see here sodium sulfate. Yes. Go to the next one. Is it okay?
Yes, below it. The example
Sorry?
2.
Yeah, number 2. Okay. I think you write here what? Mg? Yeah, G will be like this. Magnesium. Yeah. Okay. What going here? Mg is a solid. It's going to react with HCl. So HCl bond is broken down. So you can get H out of the reaction, and magnesium and chlorine combine together. Then they will get MgCl, magnesium chloride. Easy?
Wait a minute, sir. Can you repeat? Sure.
This one is HCl. Yeah, it will be broken down here. So this Mg comes toward chlorine, and it will make a bond with it. And hydrogen will coming out from here in this way. Okay?
The Mg and Cl make a bond. Why?
Yeah. So you
The
get
Mg
this is
and Cl.
magnesium plus hydrochloric acid. When they're gonna react, you get this magnesium chloride, this thing, and hydrogen. Bus. Don't worry about any other thing. That is a complete reaction. Yes, my dear. Anything else?
Yes, sir. Still, I did not understand. Metal magnesium reacted
No problem. Just a minute.
hydrochloric.
Don't worry. I'm here for you. Don't be worried. Look here. That is magnesium, Mg. That is HCl, for example. Okay? Easy? Yes. This is solid metal. It has positive charge on it. H positive, chlorine negative. Okay? Just try to understand the charges. This bond is broken down from here. Okay? And you can just understand that hydrogen has less positive than magnesium. Okay? Or you can say that magnesium is more stronger than hydrogen ion. Is it okay?
Yes. And how do I know?
How do you know? Again, you need to know the periodic table, which elements have how much polarity and charge on them. Okay, no problem. I also work with you on this thing. But first, here you understand just that if a strong element comes, it can kick out the you can say that the weaker one. So here, this hydrogen is weak and magnesium is strong. So it will come and kick this hydrogen from here, and this hydrogen run away as H positive or gas like this. And here, this magnesium take place of hydrogen, and MgCl2 will comes here. Okay. Now understand?
Yes.
How softly and how politely I explain you. Hope you enjoy the lesson. Okay, my dear. Inshallah, now see you on Saturday.
Wait, sir.
Yes?
Can I have another lesson? Because the past paper, the
Uh,
assessment is tomorrow.
let me to first stop the recording, then I will tell you 1 minute only.
Okay.